we're looking at the water cycle. And we're just going to skim the surface here. We're going to break down the sheer mechanics of how our world breathes, moves, and literally sustains life. So here is our roadmap for today. We've got 1, the engine of life, 2, up into the atmosphere, 3, back down to Earth, 4, moving across the ground, 5, our human impact, and 6, the filtration solution. This isn't just a basic diagram of rain and clouds, you know? It's a deep, real-world look into the mechanics of our planet that affects us every single time we turn on a tap. Section 1, the engine of life, understanding the foundation of our planet. Right, so before we track exactly where water goes, we really need to understand why it matters so much. Water is the absolute basis of life, growth, and our day-to-day health. I mean, 70% of our planet is covered in water. That is an absolutely staggering amount of liquid. But here's the catch. For water to actually perform all of its critical functions, to grow our food, sustain our bodies, regulate our weather, it can't just sit there. It has to be replenished, it has to be purified, and it has to be circulated again and again. An immense system like this requires a truly massive planetary engine. And that engine is the hydrologic cycle. Simply put, it's the continuous movement of water on, above, and below the surface of the Earth. And it's entirely driven by solar energy from the sun, along with the exchange of heat. You see, this exchange shifts temperatures and moisture levels across the atmosphere, the oceans, and the land, creating this non-stop loop of energy and motion. Moving to Section 2, up into the atmosphere, defying gravity. Let's look at the first stage of this cycle. We're going to treat water like an active character that has to somehow make its way from the hydrosphere all the way up into the sky. And this brilliantly illustrates exactly how that upward journey happens through 2 distinct paths. On the left, we have evaporation. This is a rapid process where water bodies, like oceans, lakes, and rivers, absorb heat energy from the sun and turn directly into vapor. A fun fact from our data, as water evaporates, it actually reduces the temperature of those water bodies. Pretty cool, right? But then on the right, we have sublimation. This is a slower process where ice converts directly into vapor without ever becoming liquid water first. This happens at extremely low temperatures or high pressures. So your polar ice caps at the North and South Poles and the ice caps high up on mountain peaks, they are constantly contributing to the sky right alongside those sweltering oceans. But the water bodies and ice caps aren't doing it alone. Enter transpiration. This is fascinating. As water precipitates, soil absorbs it, and plants take it up through their roots, pushing it toward their leaves for photosynthesis. But the extra water? Well, the plants actively pump it out into the biosphere as vapor through these tiny openings on their leaves called stomata. It is almost like the plants are sweating. Through transpiration, liquid water takes on a gaseous phase and enters the atmosphere. Which brings us to Section 3, back down to Earth, the inevitable return. So we have completely defied gravity. We've got massive amounts of water vapor floating high above us, but what goes up must eventually come down. As that vapor rises higher and higher into the atmosphere, it meets low temperatures, and this triggers condensation. The vapor cools down and changes into very tiny particles of ice or water droplets. Because they are way up there in the cold, these tiny particles begin to cluster together. They inch closer and closer until they form the clouds and fogs we see every single day when we look up at the sky. Then, wind or temperature changes cause these clustered droplets to combine into much bigger droplets. When the air simply cannot hold any more water, it releases it as precipitation. And 0 degrees is the critical threshold here. If the temperature at high altitudes drops below 0 degrees, those falling droplets lose their heat energy and fall as snow. Above that, well, it's rain. And depending on the exact atmospheric conditions, it could also precipitate as drizzle, sleet, or hail. But no matter the form, this is the exact moment water re-enters the lithosphere by landing squarely on the Earth. Section 4. Moving across the ground. Returning to the source. The precipitation has hit the ground. What happens the very second it makes impact? It becomes runoff, water rapidly running over the Earth's surface. Snow melts, heavy rain pours. It aggressively rushes across the ground. It displaces topsoil. It grabs minerals and races along to form fast-moving channels. It's this rapid, high-energy sprint straight back into our lakes and oceans, successfully returning to the hydrosphere. But not all water rushes. Any water that doesn't run off or quickly evaporate is absorbed. This is infiltration. The water slowly, methodically seeps deep down into the earth. It is measured in inches of water soaked by the soil per hour. This slow downward drive increases the level of our groundwater tables. And because the Earth acts as a natural sieve, these underground tables typically provide incredibly pure, clean water that is entirely safe to drink.
Section 5. Our human impact, altering the delicate machine.
As benefactors of this incredible natural system, we humans constantly interact with it to reach our own goals. And in doing so, we naturally alter how the machine operates. According to the data, our actions interfere with this cycle in 5 main ways. First, deforestation. Trees naturally slow down runoff and transpire vapor. Removing them increases rapid runoff and evaporation. Second, urbanization. By paving the land with impermeable surfaces like asphalt and concrete, we physically block water from infiltrating the ground, forcing it to become runoff instead. Third, agricultural practices. Things like irrigation actively move water from one natural location to another, changing the timing and amount of water available for surrounding plants and animals. Fourth, water withdrawals. When we pull water from rivers and aquifers for our homes and industries, we reduce the volume available for the natural ecosystem. And finally, climate change, driven by activities like burning fossil fuels, directly alters precipitation patterns, global temperatures, and evaporation rates across the entire cycle.
Section 6. The filtration solution, restoring the balance.
So the crucial point is, with our heavy footprint on this natural engine, how do we safely interact with it? Well, as we just learned, runoff water is highly active. It grabs whatever is on the ground. Unfortunately, that means moving water picks up pollutants from agricultural runoff, industrial waste, and sewage. The natural cycle inadvertently collects our waste, which means human intervention is absolutely necessary to clean and purify it before it reaches us. Now, what's really interesting is how cities basically mimic and enhance natural purification. To protect public health, cities use dedicated filtration plants to treat water from rivers and lakes before distributing it to your home. It involves these specific steps. Step 1, coagulation, where chemicals are added to bind dirt and particles together. Step 2, sedimentation, allowing those heavy bound particles to just settle right to the bottom. And step 3, filtration, passing the clearer water through materials like activated carbon to strip out the remaining impurities. By actively removing pollutants from the water, filtration is far more than just a city utility. As our source material beautifully states, filtration helps to maintain the delicate balance of the Earth's ecosystems and ensure the availability of fresh water for future generations. Every single thing we just learned about this planetary engine, from the ice caps to the stomata on a leaf, relies on this balance to survive. From absorbing heat in the ocean, defying gravity to form clouds, plunging back to Earth, and rushing across the soil, this system literally never stops. As water constantly circles the globe, what role will you play in its next cycle? Think about your own environmental footprint next time you turn on the tap. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.